Hi and welcome to some support for the decimal sequencing lessons. But this is going to be a bit quite generic. I'm going to go on a whistle-stop tour of things to do with decimal sequences. So there's a few things we need to be aware of. It's the word term, bit of terminology, term. That just means the number of the sequence. So if it says what is the next term, so this question here is a typical sort of SATs question, and it would be worded as what is the next term. It just means what is the next number, or what is the missing term in this sequence, okay? The nth term, not so much year 5, but year 6, definitely up into secondary school. The nth term is just, the n is the unknown part of the sequence. So this is the first term, second term, third term, fourth term. If you work out a rule for your sequence of numbers, I mean, I'm coming away from decimals a bit here. So if we had 3, 6, 9, 12, obviously you can tell that's going up in threes. But you might want to write a formula or rule for it. So you'd have n times 3. So n would be the number of term. So the first term times by 3 is obviously 3. So that's why I said my sequence was 3. The second term, 2, times by 3 is 6. So 3, 6, 9. The idea of that is because you might get a question that says, what is the 50th term? What is the 100th term in your sequence? And it just saves you writing out the 3 times table or working out the 3 times table to the 100th number or the 50th number, whatever. You just know, right, the question's asked me for the 100th term, and my rule is the term times by 3. So the 100th term would be 100 times by 3, obviously 300. Something we need to be aware of really early on when we're calculating these, are the sequences increasing or are they decreasing? So let's have a look here. So we've got 1.3, 1.6, 1.9 and 2.2. So hopefully quick mathematicians will see that it's obviously increasing for starters, but they'll know what it is straight away. But I'm not expecting year 5 to just get it straight away like that. If they want to write down all of their working out, that's absolutely fine. So what I do to start with, I'm going to take the first 2 terms here, and I'm just going to subtract them away from each other. So I've got 1.6, take away 1.3, 6 take away 3, 3 decimal points don't move, and 1 take 1 is 0. So something in this sequence is changing by 0.3 each time, and hopefully you can identify it's getting larger. So the rule for this sequence is increasing by 0.3. Let's just double check that. So this is a plus 0.3. Let's double check this one. Is it going up by 0.3? Well, 1.6 added to 0.3 gives 1.9. I'm fairly confident now that I have got the right rule for this. So feel free to take away ones where consecutive numbers you've got in the sequence. Take them away. That will work out the value that they are increasing or decreasing by. You've got yourself a rule, part of a rule, sorry. Then what is happening to your sequence? Then you work out is it increasing or decreasing. So the rule for this one, as I said, is it's increasing by 0.3. However, tests and questions are never that easy, so here we go, we've got a red box for a missing term. So we could just apply the same rule again. I did up here for my model one. We've got 2 numbers that are consecutive here in the order, there's no gaps here. Okay, this is the missing number. Okay, so one way we could do this is to take them, to do the subtraction again. We could have 2.7 take away 2.5. Okay, 7 take away 5 leaves me 2/10. 2 take away 2. So now I know the rule here is something to do with 0.2. So let's go back to our actual sequence. Okay, I don't know what's happening in there, but the numbers are clearly getting larger. So the rule for this one is adding by 0.2 each time. So we know we've got it for that one there. This now goes into the unknown. So it's 2.7 add 0.2. That's a terrible 2, apologies. 7 and 2 is 9. Decimal point, keep them in line, 2 and 0. So hopefully the missing number here is 2.9. Now if I was to add on, follow my rule again. My rule for this one is adding 0.2. I know that I've got that right. So I'm confident that rule is correct, and it allows me to fill in that missing one here. Now this one is a slightly different. The missing term has moved. Okay, and there's something else different about this sequence as well, which I'm hopefully the children will spot very quickly. This time, we don't have consecutive numbers straight away next to each other here, so you might have to go exploring. One option you can do is go looking on down the sequence and seeing what happens here. We can apply the same rule. We've got two consecutive numbers here, so I'm just going to take them away. 4.9, take away 4.5, 4 tenths. So something in the sequence is happening to do with 0.4. So from there to there, there is something to do with 0.4. Now this time I've got 5 points something up here, missing number 4.9, 4.5. Hopefully now the children have spotted that the sequence is decreasing. So the rule for this one is decreasing by 0.4 each time. Okay, important that you say these sentences out loud. Okay, to make sure the skill, the rule is fully understood. So now you can take your original number, your start number of the sequence, and you could apply your rule, which is it's decreasing by 0.4. So that would be 5.7 take away 0.4. Okay, which would give you obviously 5.3, and then you can double check it there. The other way is you could do the inverse. If you know you've done a lot of calculation over here, you're on 4.9. If you go with the inverse, you're going back up the sequence. All you got to do, you can just do an add 0.4 to go this way. Okay, if you're feeling comfortable with those digits down there, it doesn't really matter which method you go for. Okay, because both ways end up with 5.3, but it's just being aware that the overall rule, the rule for this sequence is it's decreasing by 0.4 each time. Okay. I'm going to quickly rub that out because there is another way for just another method which is perfectly acceptable. I do this sometimes. I'm just going to show you. There we go. So I started with the first number in the sequence in these ones here. So if I started here again, I know I'm going to write underneath because there's just a bit more room. Okay, again, children can write down every little bit of note they want to, any bit of thinking, anything they want to write down to save them having to remember it is absolutely fine, as long as what goes in the answer box is all they want to be marked. So I know that I've got 5.7 to something unknown. That's one in the sequence, one jump. And then I go on down to 4.9, which is my second jump. So let's just for a minute imagine we don't know what the rule is for this sequence. Okay, so I've got 2 jumps in the sequence, but this one's a bit useless to me because obviously I haven't got the number there. But we do have the start in the sequence and the end in this mini sequence. So we could subtract those away from each other. 5.7 subtracted by 4.9. 7 take away 9 you can't do, so I have to exchange. 17 take away 9 is 8. 4 take away 4 is 0, and don't forget your decimal point. Right. This time the difference though is that we've got 0.8 covers this all the way down to this number. But we've got a halfway point, we've got a step in the middle, so it's 1, 2. So this 0.8 actually accounts for 2 jumps, so we need to divide it by 2. So 0.8 divided by 2 is 0.4. So now we know each jump, so you can go, we know it's going from 5.7 down to 4.9 here, so we know it's a decreasing sequence. So you could just do your takeaway, decreasing by 0.4 from there. Whichever way, it still gives you the same answer. And if you're looking sort of even further up school and tougher sequences, sometimes the sequence is not a consistent. This was increasing by 0.3, this was increasing by 0.2, this was decreasing by 0.4. There will be questions where they are sort of 1 point something, 3 point something, okay? That was just a quick example to show you how to find them out nice and quickly. Sometimes they don't increase by a constant amount. Trick is here, you need to get down as much information as you can possibly work out. So I'm going to look at this jump here. So 0.4 take away 0.2 means there was an increase. Probably not a great place to put that. 0.2. So this was an increase of 0.2. Now I'm going to investigate this. 0.8 take away 0.4 leaves me 0.4. So this was an increase of 0.4. Important that you write down or note down each step. what you find out, because this will reveal itself in a minute. Now I'm going to look at these ones. 1.4, take away here. 4 take away 8 you can't do, so you've got to exchange. 1 for 10 in here, so 14 take away 8 is 6. Okay. And there we go. Sorry. And hopefully now this was an increase of 0.6. They're not constant increases, but hopefully now 0.2 increases 0.4, increases 0.6. Hopefully the children now are shouting at me, noticing that there is actually a pattern. Even though they're not a consistent increase, or might be consistent decrease, there is now a pattern. Now this was 0.2 increase, 0.4, 0.6. So hopefully they're screaming at me, saying that this would be an increase of 0.8 onto 1.4. Then you just got to do your decimal addition, which I know you guys are really strong at. Gives you 2.2. I hope that helps with decimal sequences, whether they increase or decrease.